All right, so for exercise 1, what I wanted you to do was to construct a frequency table and calculate the following things by hand, but I think we're going to do it in Excel instead. And so I'd like you to open Excel and input this data. Start it with an X at the top of the column and then fill in the data below. We're going to create a frequency table using something called pivot tables. And I'm just going to show you how to do it in Windows. Mac is very similar. It's under the Data tab in Macs, so that's the only thing that's different, really. And then some of the clicks and options are slightly different too, but we'll use Excel. If you have any troubles, I'm confident you can figure it out. So anyway, I'm going to create a pivot table. It highlights my data automatically if it's the only data I have. I click on OK. And what I get here is I have these options over here. Choose fields to add to report. Well, all I have is one variable, so I'm going to put that in my X. And what that does is it creates a row for every value of X that I have. If we look at this data and scan it, numbers range from 2 to 6, right? And well, that's what I get, numbers ranging from 2 to 6. Now what I also want to do is add an account row. And so I'm going to drag X into the values. And I don't want the sum of X. I want the count of X. So I'm going to click on that little arrow, highlight count, click OK, and voila, I have my frequency table. Now if I want to calculate my N, well, I don't have to because it's already done it for me. If I want to create sum of X, there are problems with cutting and pasting. So one thing I'll do while I'm working with this data is I'm going to get it out of the pivot table, because otherwise it'll keep changing as I keep moving things. So I want to copy this. I'm going to paste it right here, but I'm going to paste. I'm going to do a special paste where I'm just pasting the values, and they used to have it in verb or in words. Now they have it in these symbols. So I'm just pasting the values. Now these, I can do anything I want with these. This is my X column. This is my F column. And let me center those just so it looks nicer. So if I want to do sum of N, Excel has a nice auto sum function for me where I can just click on this. It'll give me my total. This is my N equals 20. Sum of X, well, we did it a few ways. We can multiply across. Again, this is two 2's. So I'm going to say in here it equals 2. Put in the shift over 8 times my frequency, and that gives me my formula, calculates 2 times 2 is 4. Now I could go ahead and add each, I'll do the formula the easier way actually, highlighting the cells so I know what I'm highlighting. But I don't have to do that. I can just highlight these things, click on this bottom thing, and drag it down, and it just copies the formula right in there. If I want to sum these up again, all I have to do is click on the sum key, and I get a sum of 77. Then if I want my average, I'm just going to type in this cell equals 77 backslash for divided by 20. And there I have my average. And so now I've calculated everything I need to calculate. And if for some reason, say I missed 2 2's, I add them in, I put it in there, everything updates automatically. Oh, I had 1 too many 4, change that to a 6, and again, it changes things automatically. Have 10 6's instead, everything gets updated. Very nice function, especially if you're working with information that keeps coming in every week, or if you're updating some student or worker files or any of your client files, whatever. It works out really well. So that's one thing we can do. Another thing we can do is we can create a table or a graph, I should say, by going to the Insert tab, highlighting my data, and then say I just want to represent this graphically. Well, I just click on the graph, and lo and behold, it spits one out for me. How nice. Nice and easy. We're going to do more with this in a little while. There are a lot of functions you can use with this, changing the sign, the layout. I can add values in here, make it simpler, type in my title, Who knows what this is? I don't like this little key in there, but hey, sometimes it works. And so on. So, and there's all kinds of different options that we can go with here. And we're going to work with this in a little bit. Here's another example that we're not going to really go through, but it's the same kind of thing. I have here different methods, grades, and scores, and I can put that in a frequency table too. I have 3 different methods. I can see how many of each kind there were. I can look at what my grade distributions are. And then I can also do the actual scores. Now, if I'm doing this, the problem is that there are too many values for me to just make a regular pivot table like this. And I'm going to give you an example by working with this data set. So if you can go to D2L and download the Graphing Data 2 data and go to data set 2. And what this is it is a bunch of data of high school and college students. And it gets all kinds of information about their gender, their race, socioeconomic status, type of school they went to, and so on. Self-concept, motivation, and then these bunch of standardized test scores. And as you can see, there's lots of people. We have 600 people in here. Okay? Now, if I wanted to, I can highlight, I can make a pivot table. Say I want to make one for, reading scores. Okay? So I'm going to highlight this whole thing. And actually, before I do that, one thing I'll show you when you have all this kind of data and you don't really care about stuff in the middle, I'm going to highlight the rows on the side. Go all the way up to nearly the top. It's just going to make things more manageable for me to work with. And I'm going to right click and click hide. Now what that did is it just hid columns 4 through 599, or rows 4 through 599. So I can highlight something, say like my reading scores. And it's going to highlight all those rows in the middle, but I don't have to spend all my time dragging things here and there. So suppose I want to create a pivot table out of this, right? I have my stuff highlighted, I click OK, great, and I get this same menu back. I want to put reading in rows, right? And reading in count. And what I'll also want to do again is change this from sum to count. And I have a whole bunch of data. I have 58 different, or about 55 different values, and it's tough for me to kind of get a single snapshot of how all these scores fit together. Now, if we're going to make a group frequency table, what we're going to do is we're going to create intervals. Like instead of each individual score, I'm going to kind of say, well, how many scores do I have between 25 and 30? Between 35 and between 30 and 35, and so on. And this slide gives us some guidelines for how that's done. And there are a couple steps. The first thing is you look at the overall range. You see how many points you're going to have to encapsulate. And then the second step is to see how many intervals you can use to kind of, or how long the intervals have to be in order to kind of make them come out to be between 5 and 15 intervals. Usually we're shooting for around 10, 8, something like that. Width of each interval should be a simple number. You don't want to go by 3.37s or 0.005s. Bottom score should be a multiple of the interval width. So if I'm going by 5s, the bottom score should be a multiple of 5. And then I'm going to create my table. Now, I could do that in a very tedious way by counting my individual scores, but that would be a real pain. So what I'm going to do instead is I'm going to click on just one value of my row labels. And when I do that, see up top here I get this pivot table tools, and I'm going to go to options. I'm going to highlight this square. If I highlight both of these, I can't do it. I just want to highlight this thing, and I'm going to click on group field. Now what this does is it tells me what my lowest value is, what my highest value is. And if I look at this, my lowest value is 28. Well, I'm going to make that down to 25. And then I'm going to extend this up. My highest value is 76. I'm going to extend this up to 80. Okay? And now if I think about it, from going to 25 to 80, if I went by, I could go by tens, right? And go from 25 to 85. But then that would give me 6, and I might kind of, crowd things together too much. So I'm going to see if it works by going by 5s, and I'll just see what I get. And I look at it, and I see that I have 11 categories, and I think that's pretty good in this case. I only have a couple in these, and I could even try to figure out a way to get it closer to drop those, but I think it's fine this way. And if I want to do that and turn this into a graph, I can do the same thing. I can either go to Insert, or I can go to my Pivot Table Tools and create a pivot chart, and it gives me the same options. And there we go. And so I can get in a quick snapshot, I can see, oh, most people score around this. And I kind of have this nice normal distribution, this curve, except for this right here. But if I change the interval width, that would change too. It's just kind of an artifact usually of how the data falls out and whether or not there's kind of one oddly common score or something like that. So that's how to make a group frequency table. And then here's some more examples of that. One thing with these frequency tables, though, is that we still have to consider what the real limits are of each one of these intervals. Like in the example here, we talked about real limits last week. If I have an interval of 60 to 64, what that really does is extend up to 64.5 and down to 59.5. For the interval 75 to 79, my upper real limit would be 79.5. Lower real limit would be 74.5. Likewise here, upper and lower real limits for 25 to 30 would be 24.5 to 30.5, and so on. So that's how it really goes. If you have any questions, let me know. Let's see here. Oh, and one thing about Excel that I should mention is that these row labels are actually kind of wrong in the sense that I can't have 30 in here and 30 in here. That doesn't make sense if I have a score of exactly 30. So how it really should be is this should be 25 to 29. This should be 30 to 35, 30 to 34. This should be, and so on. And it should go like that. You cannot have the same label in two rows, and that's something that Excel does that I just never understand because in the real world it doesn't really work that way. But what are you going to do? I don't want to write the people at Microsoft. You don't have to worry about doing this. You can if you want to get some more practice, but you don't have to. When you're done, it should look something like this. Now, if we're going to talk more about the graphs that we can make, the type of graph you use really depends on the type of data that you have and the scale of measurement that you're working with. So, if I have nominal or categorical data or ordinal scales, I can use a bar graph. If I have interval or ratio scales, I can use histograms. Now, histograms and bar graphs look almost exactly alike. There's just one slight difference. Bar graphs have spaces in between. And here are an example of categoricals, right? This is computer only, lecture and computer, lecture only from the example before. Here are the grades, ordinal data, A, B, C, D, F, right? Bar graphs, gaps here. If we look at what histograms look like, though, histograms have no gap between the bars because each interval is supposed to be representing a continuum rather than a category or a discrete score. And this is an appropriate number of categories here. This would be with too few, right? I can't really tell what's going on here. I don't know if all these people got 99 or if they all got 80s. And if I'm talking about these being grades, that's the difference between all C's and all A's. So I would like to know what actually is going on in there. And if we want to, just do a quick example. I can highlight this stuff again. Go to my pivot chart. I'm just going to make this basic one. And I'm going to get rid of this too. What I want to do here is I want to click on the bars and I want to format my data series. And what I want to do is make, and here I'll show you how it updates while you do it. I can control how big the gaps are, right? I can make them be little skinny lines, or I can make them be really fat here. And there's no gaps, and now I have made a histogram, which is nice and easy. It's very quick. Even if I did it with a different type of chart, right? It still plunges things together and so on, whatever I do, regardless of how I want to make it. Same thing. Histograms typically look the best like this. It's kind of hard to read the other way, and then people try to get fancy with how they manipulate things, but this is the easiest way. Another version is a polygon. It's just like a histogram. It represents continuous variables. And the idea is that I'm kind of graphing things out, and it forms this multi-sided shape. It gives me the exact same information. People don't use these, excuse me, that often, but they do sometimes, just so you know what they are. The other one is a stem and leaf display. Now, the nice thing about the stem and leaf display is that it retains all the information that I have without, but it still is simple to look at. So this and this right here give me the same stuff. The way you read one of these is that the stem is like a higher order number place. In this case, it's tens, and the leaf are ones. Now this 5 and this 1, 3 mean that I have a 51 and a 53, 62, 65, 68, and so on. Note that here I have two 76s, right? And if I wanted to say, well, what's the highest score in here? It would be 96. My lowest score is 51. If I want to count how many scores I have, well, then I'm just going to count how many individual numbers I have over here. It works well with small data sets, but if you're getting into the hundreds or thousands or tens of thousands of data points, these are kind of ridiculous to use. They don't really help you. Another thing that's nice is that you can rotate it on its side, and you can kind of look at what the graph would look like. If I graph this out, I would have, if I grouped it by tens, this is how it would be. And that's interesting. Some other things I would like to talk about with this, oops, lost my place. Come on. Is the shape of the distribution. Now, symmetry and skewness are two things we'll talk about a lot. Symmetry is going to be related to normality, and skewness means that it's not symmetrical, basically. When I have a positive or right skew, I have something in which the tail is on, well, let me actually pull up an image of it because it's easy. I usually draw this on the board, but I don't have a board right now. So I'm going to search images. I'm just going to say positive skew, and a whole bunch of graphs will come up. So here we go. I don't want that one. I want this one. Come on. So these are positive and negative skew. Positive skew means that I have my regular distribution would be symmetrical right here, but because I have a few extreme high things, it's kind of pulling everything, a vacuum, sucking it up towards the high values. Negative skew, it's the same thing, only this narrower, longer tail points towards the lower scores. Oops. So that's skewness, and make sure you can tell the difference between positive and negative skew. The second thing is peakedness. Now, I don't need you to understand or remember the terms mesokurtic, platykurtic, and leptokurtic. Meso just means your normal. Platy, you can think of it rhyming with flat, platykurtic. And peaked, you can think of somebody leaping up high, and it's leptokurtic. But peakedness just kind of talks about whether or not I have really, well, I'll put some in here. Here I have my three examples. Leptokurtic, too many people all in the center. I don't have enough people in extremes, and people don't kind of gradually fall off. Mesokurtic is this nice normal kind of bell-shaped curve, and platykurtic means that too many people are in the extremes, not enough people are near the mean. In terms of modalities, when I talk about the mode of something, I'm talking about the most frequent score that they have. In the case of distributions, when I have more than one hump, basically, I'm talking about a bimodal. If I have three, it's trimodal, four, it's quadmodal, and so on. And you can keep going, but usually we just say multimodal after three, because then it doesn't really matter. What this usually tells you is that your population, if say these are voters, right? If, depending on the question, there's something about the people or my data points that means I could really group them into two separate categories. And suppose that these were like President Obama's approval ratings. These are low ones, these are high, and you see that these would probably be more the Democratic or liberal people. These would be probably more the conservative or Republican people, and then you got the independents in the middle and stuff like that. But it means usually that you can separate your population into two meaningful subpopulations. Now, you can go through these stem and leaf questions if you want. Let me know if you have any questions, but there are some in the quiz online, so I'm not going to go over that. We do also need to go over percentiles and percentile ranks. And then we're going to do some work with Excel, but I'll put that in a different video because this one's getting kind of long. A percentile rank of a score is the percentage of individuals who scored at or below a particular value. If we want to talk about the formula, it's cumulative frequency divided by n times 100. And we'll talk about cumulative frequency in a second. When a score is identified by its percentile rank, the score is called a percentile. In order to determine percentile ranks or percentiles, we must first calculate cumulative frequency and cumulative percentages. Now, if you look at this, I think even if you just looked at it, you could figure out the pattern, right? We start at the bottom, and when I get up to the top, my cumulative frequency should always be equal to the number of people that I actually have. Starting at the bottom, if I look at my data, I have 2 people in this range. So my frequency here is 2, and my cumulative frequency is 2. When I go to the next one, I have 0 scores in this range, okay? My cumulative frequency is this interval plus everything below it. So this would be 0 plus 2 gives me my 2. Go up to this one, I have 1 in this value. So my cumulative frequency equals 1 plus 0 plus 2. This is 5 to equal 2 plus 1 plus 0 plus 2, and so on all the way up to the top. And if I don't have the same number of people that I have in my sample or my population that I'm making this chart out of, well, then I made a mistake somewhere. For when we're then switching to cumulative percentages or relative percentages and things like that, I am just going to divide the cumulative frequency by my total frequency. So in this case, I have 2 people here, 10%. 2 people still in the cumulative frequency, because remember I didn't add anybody. This is still 10%. Now, this represents then the 10th percentile, meaning that 10% of the people scored at or below this level. When I'm looking at this interval, right, I had 2 people who scored here. 2 out of 20 would only be 10%, but because I'm talking about cumulative percentages, it's 8 out of 20. 8 equals 2 plus 2 plus 2 plus 1 plus 0 plus 2, right? So 8 divided by 20 is 0.4. That's 40%. So 40% of the people scored at or below this value. The value that actually equals the 40th percentile is the upper real limit of this interval. So it would be 79.5. That's my 40th percentile. Just like if I wanted to know what is the 75th percentile, it's the upper real limit of this interval, 89.5. Likewise, if I want to know what percentile rank any one of these scores is, the best way for me to do it is to just look at the real limit of an interval and say, what's the percentile rank of 54.5? Well, that would be 10%. If I asked you what the 30th percentile is, well, then you're going to look at the interval and say, oh, it's 74.5 because that's the upper real limit. Percentile rank for 64.5, I find that interval, it's the 15th percentile, and so on. And I hope you don't have any questions on this. Now we can think of this as probabilities, and again we're going to be shifting into probabilities in a couple weeks. And if I said I was picking one student at random, what's the probability that they will have a score at or below 49? Notice the questions are phrased in terms of percentile ranks. Now in this case, at or below 49, I don't have anybody in that range. So I would say that it's 0. Nobody got that low. What is the probability that a student would have a score at or below 69? Well, here I'm looking at this interval and I'm saying it's 25%. I could ask it as 69.5, but we just have whole numbers here, so it'll work for this. What is the probability that the student will have a score at or below 89? Again, look at the interval, 75%. So 75% of the time I will get a score that falls in that range of 89 down to 50. And so we can think of these as probabilities, and we're going to be doing a lot more with this in talking never really about single values, but always about ranges of values. But that'll become clear as we go. So if you have any questions on this, let me know. And I'm going to move on to the graphs, but I'm going to do a new video, so there'll be a different link for that one.